In today's lesson, we are going to continue working with solving equations. But today I'm going to teach you a new strategy and hopefully it will get you in the mindset of combining like terms when working with constants and variables. So in today's objective, students will be able to solve equations for a missing value by grouping constants and variable expressions. So let's go ahead and review over how to identify what looks like a constant and what looks like a variable expression. So given this equation, notice that there are two sides to this equation, the right and the left side. On this side we have 6h to the fourth plus 9h minus 5. The other side we have 23 plus 8h squared. So we want to get into the mindset of identifying which part of the terms are variables and which parts are constants. So this whole term right here, 6h to the fourth, is going to be our variable, so I'm going to label it with a V. 9h has a letter in it, and I'm also going to label that a V. When I see a number isolated on its own and it's not next to any letter, it's no longer a variable expression, it's just a constant. And similar with the other two terms on the right side of the equation, we have a 23. That is a constant because there's no variable. And then we have 8h squared, which is a variable because we have the letter h in our term. So we want to be able to identify a lot of the constants in our equations and the variables in our equations in order to know which parts to combine together. So let's go ahead and review on what combining like terms looks like when we're using inverse operations. So let's go ahead and combine constants in this first example. We have 8n minus 5 equals 2. So like we've done before earlier, we have to label the parts. Here's variable, here's a constant, and here's a constant. So since I want to combine constants together, I want to do the opposite, which is the inverse operation. I know that I am subtracting a 5, or in this case there is a negative 5, so in order to get rid of that negative 5, I need to somehow include a positive 5. And the positive 5 is in essence adding a 5. So I want to add a 5 to the other side of the equation to balance it because I want to do the same thing on both sides. Nothing is happening to that variable expression, so I can just bring it down. A negative 5 with a positive 5 will then cancel out, and then I have 2 plus positive 5 to give me 7. That is balancing an equation by combining like terms that are constants. Let's go ahead and take a look at how to combine like terms when we're working with variables. So we have 4b cubed plus 2 equals 9b cubed. So we want to label, here's a variable, here's a constant, and here's a variable. We can't combine constants and variables. We can only combine variables with variables only if they have the same expression. So this is a b cubed and this is a b cubed, which means we're okay to combine them together. So let's take a look at bringing this 4b cubed over to the right side. So we notice that there is no sign in front of that 4, so we're going to assume it's positive. If it's a positive 4b cubed, in order to get rid of it, we have to look at its inverse, negative 4b cubed. So since we are subtracting that 4b cubed on the left side, we also want to do it on the right side to balance that equation. So a positive 4b cubed and a negative 4b cubed cancels out to a 0. The constant stays there because nothing is happening to it and we're not combining it with other constants. And then we have a positive 9 and negative 4, which gives us a positive 5. And then our variable expression, b cubed. So I know that my coefficient is a positive 5 because I started off with positive 9s, and I'm going to combine it with a negative 4. Since there are more positives than negatives, I know my answer is going to be positive. So that 9 positives with 4 negatives gives me 5 positives. So let's move on to solving some equations. I have 6z minus 27 equals 11 plus 8z. So today, I think I want to introduce a new strategy on solving these equations because I think the OIR method is tripping you guys up because it's hard to identify what the operations are and what numbers you're going to be used once you're working with negatives and positives. So I want you to get into the new mindset of I want to group constants on one side of the equation and I want to group the variables on the other side of the equations. So we don't want to mix constants with variables. So given the equation that we see right now, we have variables mixed up with constants on each side of the equation. We want to find a way to make sure that only constants are on one side and only variables are on the other. So let's go ahead and label this equation so we know which to work with. So here's a variable, here's constant, constant, variable. So let's go ahead and move the variable to the right. If I move the variable to the right, I need to make sure that I move the constants to the left. That way, I have all my constants on one side and all my variables on the other. So if I have a positive 6z, I'm then going to add a negative 6z on both sides. Remember, addition of the opposite is in essence subtraction. So I'm going to write it over here in the form of minus z 6z because I started off with a positive. So I'm going to make sure that the inverse is negative. So once I do that, I get rid of my 6z. 8z minus 6z gives me 2z. Notice how all the variables are now on the right side of the equation. And then now I can work with my constants. If I'm moving my 11 from the right to the left, I started out by adding 11, so I need to subtract 11 on both sides. Subtract 11. So I have negative 27 with another negative 11, so that gives me a negative 38 equals 2z. Once I get to this equation, it's just a one-step equation, and I know that the z is being multiplied by 2, so I'm going to do the opposite, which is divide. And when I divide both sides by 2, I get an answer of negative 19 equals z. Let's try another example. I have negative d minus 126 equals 36 plus 8d. So let's go ahead and choose the sides that we want to move the constants and the side that we want to move the variables. So let's go ahead and move the variable this way and the constant this way. So I started off with a negative d, so then I want to do a positive d to both sides. I started off with a positive 36, so I'm going to end up with a negative 36 on both sides. Now I'm doing both steps at the same time so that I can solve all the equations neatly at a time. The negative d with a positive d cancels out to 0. The positive 36 and the negative 36 cancels out to 0. So now we have all constants on the left and all variables on the right. So a negative 126 and a negative 36 is going to give me a negative 162. A positive 8 and a positive 1 is going to give me 9, and my variable is d. From here, you can just take a few seconds to go ahead and solve for d by applying the inverse. And if you solved correctly, you should have gotten an answer of negative 18 equals d. Let's go and practice another problem. This time I'm just going to point the direction in terms of where you're going to organize. This time let's move the variables to the left side of the equation, and let's move the constant to the right side. Remember, we want to get in this mindset since that equations are always balanced because of this idea of equality. It doesn't matter which number or which constant or variable we're moving and in which direction, as long as we're applying the inverse on both sides. we're going to end up with the same exact answer. So since I've already identified the direction you're going to do it in, I want you to take a moment to find the answer to G by combining and grouping constants and variables together by applying their inverses. So I'm going to take you a moment to solve for G. Good, so if you had solved this problem, you would have added a 7G to both sides. Added a 7G because you started off with a negative 7G, so you're going to have a positive 7G. If you are going to move the 63 over to the right side, since you subtracted a 63, now you have to add a 63. So when we add the 63 both sides, when we balance this equation, we only have constants on the right side and variables on the left side. So we have 11G equals 143. Once we get to this stage, it's a one-step equation. You divide both sides by 11, and you get G equals 13. Lastly, I have one more problem for you to try on your own. Again, same process. Move and group the variables to one side. Move and group the constants to one side, to the opposite side, and then you'll end up with a one-step equation. And typically you're going to solve by doing the inverse, and then you'll find out the answer to P. Good luck, and I hope this strategy has made this concept a little bit easier for solving equations.